Good morning, students. For last lecture, you have learned the silver lead system or lead silver system, and all of you know lead and silver. These are the two solids, and all the phases involved in this system are explained with the help of lead and silver. So it is a two component system. And if we have taken lead as a component A having melting point 327 on this axis, here that means here we have 100% Pb lead and 0% silver. Then at this B point, it is the melting point of silver and it is 961 degrees centigrade, and here we have 100% silver and 0% Pb and 0% Pb. Then here, as I have told you, if we have lead and silver and the mixture of lead and silver, if we hit well above the melting points of these two, that means above 961, we have the molten mass or the solution of lead and silver, and this is a homogeneous solution or molten mass of lead and silver. The region here above the points A, O, B, we have a single phase. That is the molten mass of lead and silver. And to describe any point in the region, we require two variables, and that two variables are temperature as well as composition. Hence, by applying the phase rule, reduced phase rule, we have degrees of freedom F, it is equal to 2. Okay, then along the curve AO, this is a melting point curve of lead and it decreases due to successive addition of Pb, successive addition of silver into lead up to this O point, and O point it is the eutatic point. O point it is a eutatic point, and again the end of freezing means beginning of melting. End of freezing means beginning of melting. So this AO curve, it is also called as freezing point curve of lead, and along the curve AO, the freezing point of lead it decreases due to the successive addition of silver into the lead. And as already you know, as soon as we arrive any point, suppose this is a Y point, suppose this is a Y point and this is a X point. X point, at this X point we have a molten mass or a liquid, homogeneous liquid of lead and silver, and we cool this composition, and up to this temperature we cool this composition without any change. But as soon as we arrive at this Y point in the liquid mixture, a solid PB, it separates out. That means freezing of the lead, it occurs. Then on further cooling, the solid PB, it separates out up to this O point, and this O point, it is the eutectic point having temperature 303 degree centigrade. At this O point, we have three phases are in equilibrium. Here molten mass, here it is solid PB, and to the right of this we have solid Ag. So at the O point, the degree of freedom is 0. Then along this BO curve, this B point, it is a melting point of silver, and this melting point of silver, it decreases along the curve BO due to the successive addition of Pb into silver, and along this BO curve, two phases are in equilibrium. Two phases are in equilibrium, and that two phases are solid Ag and the molten mass of Pb and Ag. Then by the application of phase rule, the curve is univariate. Suppose we have a liquid composition and we cool this, and if we reach at this point M, and this point M, it is on the curve BO, at this we separate a solid, here solid silver. Okay, we separate here solid silver. Then again on further cooling, the percentage of silver, it goes on increasing. The percentage of silver here goes on increasing, and at the eutectic point we have 2.4% silver, and the application of this phase diagram of lead silver system, it is in the Pattinson's process of desilverization of lead, and the ore called argentiferous lead, it contains only 0.1% silver, and this ore is heated well above the melting point, and the cooling of that molten mass, it is carried out, and we separate the silver by using this phase diagram. This is the explanation of lead silver system. Then we will see the next two component system, and that is the Ki water system. This is the phase diagram of Ki water system. It is also called as the freezing mixture, and freezing mixture, in this diagram you will also learn the theory of freezing mixture. Then in the two component system Ki and water, the phases involved are solid Ki, ice, solution of Ki and water, and the vapor phase. And the vapor phase, it has no any vapor phase here we neglect, so we kept pressure constant, and we draw the diagram of temperature versus composition. Temperature versus composition. Here the phase diagram of Ki water system, it is represented in this diagram. Here A point, it is the freezing point of water. At this axis, we have 100% water, and at this axis, we have 100% Ki. Here, the freezing point of water, it is a 0 degree centigrade. It is shown here. And the melting point of Ki, it is very high. So, it is not possible to represent this B point on the axis. Remember well. In case of any salt water system, the melting point of salt, it is never shown on the axis. Then this curve AO represents the decrease in freezing point of the water along the curve AO due to successive addition of Ki into water. And this curve OB, it represents the solubility curve of Ki. That means as we increase the temperature, the solubility of the salt, it goes on increasing. And along this curve AO, two phases are in equilibrium, ice and solution. So the curve is univariate. In this area, we have a saturated solution of Ki and water, and along this curve BO, two phases are in equilibrium. Here, solid Ki and solution. And this O point, it is a eutatic point, and at the eutatic point, we have three phases: ice, solid Ki, and solution. So this eutatic point, it is a univariant system, or F, it is equal to 0. And at the eutatic point, we have the percentage of Ki, it is 52%. Then suppose we have a liquid composition here represented by M point, and we pull this liquid composition. Then at the temperature 23 degrees centigrade, in the solution, the solid ice as well as solid Ki, it separates out. So this line CD, it is called as solidus, because two solid phases, here ice and here solid Ki, they coexist. This is the explanation of two component system, Ki water system. And as this temperature is a 23 degrees centigrade, at this minimum temperature we have in the solution here solid ice as well as solid Ki and the solution of saturated solution of Ki and water. This O point, it is a eutatic point. Then see the another phase diagram of sodium chloride water system. Sodium chloride water system. It is also a two component system. Here, as usual, A point, it is a freezing point of water or melting point of ice. Along this curve, AB, two phases are in equilibrium, ice and saturated solution of sodium chloride and water. And here, again, they have not shown this C point on the axis. Here we have 100% water and here we have 100% salt. Then in this area we have ice and saturated solution of NaCl in water, and here we have solid NaCl and here the solution. Again the B point, it is a eutectic point, and at the eutectic point three phases are in equilibrium. Ice, here it is the NaCl and here it is a saturated solution. The curves are univariant and the eutectic point, it is a non-variant system. This is the another example of salt water system, and this temperature, it is minus 21.2 degrees centigrade. So this point, it is also called as cryohydric point. This point, it is also called as cryohydric point. Then see the phase diagram of magnesium and zinc system. Here, this is the combination of two simple eutectic systems. This is the combination of two simple eutectic systems. Here we have 100% zinc here, and here 100% magnesium, and zinc and magnesium, their alloy, it will melt at a lowest temperature 380 degrees centigrade, and here the second eutectic point, here it is 347 degrees centigrade. Then the next point, it is formation of compounds with congruent melting point. And the congruent melting point, it is the melting point at which the composition of solid and its liquid, these two compositions are same one. Then for the next lecture we will see how the phase diagrams of two component systems with congruent melting point are explained and what are the proper examples. And for your study there is a ferric chloride water system. We will see later on. दाद्या, तू एकदा बाथरूम मध्ये शिरलास का नाही? किती बदा 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 पाणी ओततोयस? अरे जरा पाणी कमी वापर की, तिकडच्या बाथरूमला जात जा.